In this video, I'm going to use the northwest corner method to find the initial basic feasible solution for the given transportation problem, and that is three sources F1, F2, and F3 for destinations A, B, C, and D. What we are having in these small squares there, and that's the unit cost of transporting a unit from a source to a destination. So for us to use the northwest corner method, I'll start by looking at the northwest corner direction. When we look at the compass there, the northwest corner direction is the top left hand corner. So in this case, we look at the transportation problem that we are given. We look at the cells where we want to make allocations. In this case, we want to make allocations in these cells that I've highlighted there. So for these cells that I've highlighted, we look at the top left-hand corner cell. The top left-hand corner cell is this one here. So we try to allocate as much as possible in this cell. To see how much we can allocate, we look at the supply constraint is a 20 and the demand constraint is a 10. So what we do is we take the minimum of these two values here. That minimum there is a 10. So we can allocate 10 units in that cell. But when we allocate the 10 units in that cell there, what it means, we have reached the demand constraint for this particular column. So we can no longer allocate any more in that column where we have the A there. So I'll cross out to indicate we can no longer allocate, cross out, we can no longer allocate there because we have already met the demand constraint there. But if you are looking at the row where we have the F1 here, what we allocated 10, but we are having a supply of 20. That means we still have 10 remaining. So I can just write the 10 there on top to say that we have 10 more we have to allocate in this particular row. So I will now go on to the next top left-hand corner cell after we have eliminated this column here. The top left-hand corner cell that we now have is this one here. So we have to allocate as much as possible in this cell. To see how much we can allocate, we look at the supply constraint, is this one here. We are saying we are left with this 10. And for the demand constraint, it's a 15. So what you do is we take the minimum of these two values, the 10 and the 15. The minimum there is the 10. So we go on and allocate 10 units there. But now when we allocate the 10 units there, that means we have now reached the supply constraint for this row. So we can no longer allocate any more in this row. So I'll cross out here and I'll cross out here, indicating that we can no longer allocate any more. But looking at this column here, it is a demand constraint of 15. We have just allocated the 10. So the remaining there that we can allocate is the 15 minus 10, which is a 5. So I'll just write the 5 there. So I'll now go on to the next step. We are now looking at the top left-hand corner cell after we have eliminated this column and this row. The top left-hand corner cell, which is remaining there, is this one here. We now try to allocate as much as possible in this cell. To do that, we look at the supply constraint, the 25. The demand constraint, we said we are left with the 5 here. So we look at the minimum of the 25 and the 5. That minimum is the 5. So we can allocate 5 units there. But the moment we allocate the 5 units, the 10 plus the 5, it gives us the 15. So we have now met the demand for destination B there. So I'll cross out to indicate we can no longer allocate any more in this column. But looking at this row here, it has a supply constraint of 25. We have allocated 5. So the remaining there that we can allocate in this row, we still have 20 more. So I'll now go on to the next top left-hand corner cell after we have eliminated these two columns and this row. That cell there is this one here. And we look at how much we can allocate there. We look at the supply constraint. We are saying we are having a 20 there. and the demand constraint is a 15. So we look at the minimum of this 20 and this 15. The minimum of 20 and 15 is the 15, so we allocate 15 units there. And when we allocate the 15 units, that means we have met the demand constraint of this 15. So we can no longer allocate anymore in this column. So I'll cross out to indicate we can no longer allocate anymore in this column. But when you are now looking at this row, it had a 25, but we have allocated a 5 and a 15, which adds up to a 20. So that means we are now left with 5 to allocate in this row. So I'll just write the 5 there to indicate that is what we are left with. Then look at the cell that we need to allocate. We are no longer including these columns and this row. So the next cell that we're supposed to allocate is this one, top one. So we look at the supply constraint. We are saying we are left with 5, and the demand constraint is the 20. So we take the minimum of this 20 and the 5. That minimum is a 5, so we allocate 5 units there. And when we allocate the 5 units, that means we have met the supply for this row. And when we have allocated a 5 in this column, our demand here, our constraint is a 20. We have allocated a 5, so what we are left with is a 15. And now we look at the cell that is left is this one here. So just highlight it there. And we need to check how much we can allocate there. We are looking at a supply of 15. And for the demand, we are left with the 15 there. So we're just looking at 15 and 15. So the maximum we can allocate there is a 15. And when we have allocated that 15 there, then we would have made all the possible allocations. Because we are having all the cells now, they have an allocation or they have been crossed out. So that's what we are having now. And we just need an interpretation of what that table is saying. So I would run another table where we have destination, allocation, and cost. So when we are looking at this 10 here, from source F1 to destination A, we are allocating 10 units. So I'll write the 10 units there. But the 10 units, we are allocating the 10 units at a unit cost of 10. So if 1 unit costs 10 to transport, we are allocating 10 of them. Cost there for all the 10 units will be 10 times 10, which gives us a 100. Then for this part, we are saying we are allocating 10 units from source F1 to destination B. I'll write F1 to B. We are allocating 10 units. The 10 units, the unit cost you are saying is a 0. So the cost there will be 10 times 0, which will give us a 0. And then on this part here, we are saying from F2 to destination B, we are allocating 5 units. 5 units at a unit cost of 7. So the cost there will be 5 times 7, which gives us a 35. On this part here, we are saying from F2 to destination C, we are allocating 15 units. 15 units at a unit cost of 9. The cost there will be 15 times 9, which will give us 135. And on this part here, we are saying from F2 to D, we are allocating 5 units. 5 units at a unit cost of 20. So the cost will be 5 times 20, which gives us a 100. And then here, we are saying from F3 to D, we are allocating 15 units. 15 units at a unit cost of 18. So the cost will be 15 times 18, which will give us a 270. Then we add up the costs which are in this column there. Then we get a total of 640. So what we are having there is the northwest corner method is giving us the minimum cost of the transportation problem is 640. So that's the initial basic feasible solution using the northwest corner method.